carryover from other pipe channels. So that's the particulate step. And we have, as you see the schematic as we go forward in the presentation, we have a filter that's built in, and then there can be need for additional filtration off of the skid depending on the particular application. And then as far as the moisture contaminant goes, that can come from the condensation within the process itself. It can come from atmospheric conditions. I was really, really surprised to learn in the success story that we'll get to at the end of the presentation how much actually occurred from humidity. It just absorbs into the oil. So that's very, very common. Also, seal leaks or equipment cleanup, when you actually go and you intentionally do periphery cleaning, that might absorb more moisture into the oil. And finally, the makeup oil. As we said in the beginning, the oil doesn't necessarily come as dry as you would like it or as particulate free as you would like it. And this unit will upgrade the incoming oil through filtration. I'm not sure how familiar you are with oil cleanliness standards. That's why I have this slide in here. But there is a standard which ISO developed back in '99 to define an oil's cleanliness, and it's a 3-digit code. And that code represents how clean that particular oil is. And so when you're purchasing from a supplier, they will give you a range of options of how clean, and usually the machinery has a definition of how clean the oil should be, just like you do for your car.
Our turbine oil, I think, is 1310?
1310?
No, 1613, right? 1613
Okay.
for our turbine oil.
Okay. So the cleanliness code is defining these 3 different micron values. Is everyone familiar with micron, I assume? Okay. So it's the level of particulate that's greater than 4, greater than 6, and greater than 14 microns. So basically, if we were looking at this 21, 19, 16 example, we'd say, okay, over here on our scale on the far right column, we've got 21, which means there are 10 to 20,000 greater than 4 microns. And the 19, we've got 2,500 to 5,000 greater than 6. And then down here at the 14 level, we've got 320 to 640 greater than 14. So that's a pretty clean oil. And of course, they can go finer, as you guys are with your turbine oils. Exactly. It's time to hand it over to Dave.
Big handoff. I get to do the fun stuff.
You get to do the fun stuff.
Yeah, as Beth was just saying, obviously the particle cleanliness is an important component. The good news is in turbines, you guys generally have a pretty good handle on that.
No,
okay, I'm starting.
Jim and I have a plant that we have a particular problem with moisture and contamination. And we have water, that unit has water glands on it, and we seem to get water in it all. It seems to be lots of water in it, but when they do samples, they don't get a lot of free water, so it must be the salt moisture in the oil, because we get we have lots of problems with that on the water on water in the oil, and and then we have on the oil side. I mean on the contaminant, we have submicron precipitation out of it. We can coat the inside of our bearings with it comes out in the bearings, and it takes out the clearance, and we end up having them. So I'd be interested in knowing if you had anything that take out super fine particles.
Yes,
We do.
Yes.
Oh, yes.
Are you sure you're not part of this
We
team?
coordinated that.
Plants.
Was that a team response or not?
And Janet went and got her pen out when he said you had plant issues. He tried to take names. You guys said that water was definitely an issue. Do you know, are you guys doing your own oil analysis or do you send it out?
They've done both.
Okay.
We've done it internally, and we've done it as a check. We've had it sent outside.
Okay, because some of the systems don't really see water at a very low level. A lot of the little mini labs they put in plants, about 1,000 parts per million is their resolution,
Okay.
which is in a turbine oil, that's very high already.
Mm-hmm.
But I do have a story where there was a plant in the southern part of the country that for 5 years had been running their oil, doing their own analysis. Hey, this is always good, you know, we're always inspect. We brought in one of our systems, and they looked at it, and they're like, oh, this moisture sensor of yours isn't working, because we have a moisture sensor on board. And it said, basically, saturated. The guy's like, yeah, we've had one of those sensors here, they never work. It's always saturated. We started looking at their oil analysis, and sure enough, that the technique they were using started at 1,000 parts per million. The oil saturates at about 160. So they were running, they had a threshold of 1,000 cutoff, although when we called their technology leader at corporate, he said, no, it's 300. Like, you guys don't even have the tools to measure it.
Mm-hmm.
So it was an interesting experiment, but the beauty is the technology for dehydration got them down into, within 2 weeks we were at 30 ppm. After that went down to 20. No reason it won't stay there. And they may have a similar problem, because we've taken that chart of the moisture content of the oil, which was obviously declining, but every time they changed load on that turbine, skyrocketed. So when they changed load, when that turbine basically went from idle or low level to a high load, they'd put in 300-400 parts per million of water, and then it would clean it back up. But every time the load changed, we saw a spike in water. And they said that's indicative of that particular turbine. They have 7 turbines on site. One doesn't, the other 6 don't have the problem. So it's something to do with that unit. Anyhow, so when we talk about water as a contaminant, you know, it exists, I would say, in 3 forms: free, emulsified, and dissolved. Free water is obvious. You know, you take a sample, a bunch of water in there, it's free. Emulsified is essentially, it can be a chemical or a mechanical emulsion. Going through pumps at high velocities, you'll really churn up really small water droplets, and they'll get very stable in the oil. You know, and that's the obvious one when you look at it. You should be able to read through an oil sample. If you can't read because the light blockage is there, then you've got a good emulsion. So that's your second phase. And then the dissolved moisture is the third phase. It's also obviously the most discrete. Once fluids reach a saturation of dissolved moisture, then you get the emulsion. Once you get past your basic emulsion, you get free. And really, we're after all of it, as Beth's example showed. Whether it's free, emulsified, or dissolved, they all contribute. And in the example she had, they took an oil that was at about 250 ppm on a turbine oil. That's right around your operating saturation level at operation. So about 250 ppm moisture. By cutting it to 40 ppm, which is a quarter of its saturation level, 20% saturation, down to here, all of a sudden you've got this huge cushion in the oil. You've got all this space that's available for discrete moisture that comes in. Because moisture is going to come in. These machines heat up, they cool down, they breathe. They're a very humid environment typically, so they're going to pull moisture in. So the key with the technology is getting it out. And we want to do that on a continuous basis. A lot of facilities, power and other types, rely on water conditioning on just a periodic basis. They'll wait until they've got all they can handle, then they'll try and get rid of it. Really with the Driflex, the whole thought is, why not take it out more or less at the rate it comes in? So instead of waiting until you get 10,000 gallons of really wet oil, let's treat the 100 parts per million that's coming in each week, and that's all we have to remove then. So again, with turbine oils, one of the reasons you do want to, I guess I'll just touch on this real quickly, you do want to make sure you're getting sufficiently below saturation, as again, best example down to about 40 ppm in this case. When this turbine, if this unit cycling goes on and off service, when that oil cools back down to room temperature, you'd have condensing water again. So what happens is you have a machine when it's running hot, or moisture's all dissolved into the oil, it's kind of out of the way. When you shut it down, the machine cools off, you'll actually start condensing the moisture inside the gear, inside the turbine itself, which is going to lead to, obviously, to corrosion. So before we tell you how our product works, we're going to show you how the other ones don't. basically we have about 3 technologies that are very common in our view of this industry. Centrifuges, this